Odysseus gets all the credits for being a legendary tactical genius. You know the story. Build a giant wooden horse, stuff 30 or so elite Greek soldiers inside, and let the Trojans drag the structure into the city of Troy. Except, if you actually hand an ancient structural engineer those blueprints, physics starts throwing hands. Because hiding 30 fully armed men inside an elevated wooden box is a brutal engineering problem involving structural loads, its build-up, and complications regarding breathable air. Could the Trojan Horse actually work, or would the Greeks have asphyxiated before the gates even opened? Let's break it all down. Most later traditions often place somewhere between 30 and 50 Greek warriors inside the horse. Now, a fully equipped ancient hoplite carried around 30 kilos of bronze armor, shield, and weapons. Add average human body weight, and your total payload alone is roughly 3,000 kilograms, or 6,600 in so-called freedom units. To hold that weight suspended several meters off the ground, a timber frame large enough to hide them could easily weigh about 15,000 kilograms on its own. Therefore, our total system weight hypothetically nears 18 metric tons, and this is where gravity comes in. That much weight concentrated high above the ground creates this huge bending moment at the joints, and unless the leg were massively reinforced, one bad bump could split the frame. But assuming Epius, the horse-ship architect, braced the joint with internal diagonal cross framing, it passes step 1 and doesn't instantly collapse. Now, how do you move this massive weight across coastal terrain into the city? Narrow wooden wheels would dig into soft ground under that much weight. You need solid log rollers or massive wooden disc wheels. Consult the god of mathematics regarding the rolling friction on the terrain, and you will need roughly 1 or 2 metric tons of sustained pull to move the horse. How much force is that? Around 150 to 200 Trojan citizens pulling in unison on thick hemp ropes should get the job done. And for a hyped-up city celebrating a gift for Athena, that is actually totally doable. They could even hook up a team of real horses to pull the fake horse that is definitely not heralding their doom. In a nutshell, moving it works, but let's step inside the horse with the Greeks. 30 heavily armed men, packed shoulder to shoulder in a tight wooden box under the blazing Mediterranean sun, could generate roughly 3,000 watts of continuous heat. That is literally equivalent to turning on 2 space heaters inside a closed closet. Without proper ventilation, humidity would climb rapidly, turning the interior into a hot, miserable space. But worse, carbon dioxide. An adult male in such cramped and stressful condition could exhale roughly 20 liters of CO2 per hour. In a sealed 15 cubic meter chamber, carbon dioxide would begin building almost immediately and would reach dangerous levels long before nightfall. To prevent this, the horse would likely have needed concealed air vents, most likely hidden in the main eyes or nostrils, to keep fresh air flowing through the compartment. So, all in all, could it work? Structural integrity, yes, with proper timber bracing. Logistics and movement, yes, via basic rolling physics. Life support, only with engineered air vents and heat tolerance. You see, Odysseus and Epius didn't just win with clever deception, they won a high-stakes game of extreme weight and thermal management. If the legend has any basis in reality, the greatest achievement wasn't building a convincing horse, it was building one that didn't collapse, suffocate its passengers, or get stuck halfway to the city gates. And because of that, they won the war, etched their names in history, and lived happily ever after. Or something. Stay positive out there, and do subscribe to appease the YouTube gods.